The automotive air conditioning compressor you see here is the heart of your car's AC system. Its main job is to take low-pressure refrigerant gas from the evaporator and compress it into a high-pressure, high-temperature gas before sending it to the condenser. The entire process starts at the pulley, which is constantly driven by the engine's serpentine belt whenever the engine is running. However, the pulley alone does not drive the compressor. It spins freely on a bearing until the AC is turned on. When you press the AC button in your car, the climate control system sends power to the clutch coil located behind the pulley. This coil acts as a powerful electromagnet. Once energized, it creates a magnetic field that pulls the clutch plate, which is mounted in front of the pulley, into firm contact with the pulley face. At this point, the pulley, clutch plate, and clutch hub become locked together and begin to rotate as one unit. This is the distinct click you sometimes hear when the AC engages. The clutch hub is directly connected to the drive shaft, so as the clutch engages, the drive shaft starts to spin inside the compressor housing. The real magic of compression happens because of the swash plate, also called a wobble plate, which is mounted at an angle on this rotating drive shaft. As the drive shaft turns, the angled swash plate does not spin flat but instead wobbles. This wobbling motion is key because it converts the rotational energy from the engine into a linear, back and forth motion. Riding on the surface of the swash plate are several pistons. In most modern automotive compressors like this one, you will typically find 5, 6, or 7 pistons arranged in a circle around the drive shaft. Each piston sits inside its own cylinder bore within the cylinder block, which is also called the rear head. As the swash plate wobbles, it pushes each piston forward on one side of its rotation and pulls it backward on the other side. This means the pistons are constantly reciprocating as the shaft spins, and they are always out of phase with each other to create smooth, continuous compression. Now let us follow the refrigerant path to understand the compression cycle. Low pressure, low temperature refrigerant gas from the evaporator enters the compressor through the suction port, which is clearly marked as the low pressure side. This gas flows into the front head of the compressor and then into the area behind the pistons. As a piston is pulled back by the swash plate during its suction stroke, it creates a vacuum in its cylinder. This pressure difference forces the suction reed valve to open. Reed valves are thin, flexible metal flaps on the valve plate that act as one-way doors. The open suction reed allows refrigerant gas to be drawn from the suction port into the cylinder. As the drive shaft continues to rotate, the swash plate pushes that same piston forward in its compression stroke. The forward motion immediately increases the pressure inside the cylinder. This higher pressure slams the suction reed valve shut, preventing gas from flowing back out the suction port.